Hey, it's Flora. A little detour before we start the show. We are rounding up your questions about roads. What confounds you about traffic or how interstates are laid out? Are there certain road design elements that ignite your road rage? Call us and tell us about it. We've got a traffic engineer in the passenger seat this week, ready to answer your questions. 877 4 SciFri is our number. 877 4 SciFri. That's 8774 724 374. Okay, now on to the show.
This is Science Friday. I'm Ira Flato. Today on the podcast, a new antibiotic that's literally a sweet surprise. But first, the importance of interjections. You know, those filler words we all say like, and huh?
Linguists used to think they were sort of the detritus that accumulates around the edges of conversations, but it's turning out that they're actually doing a lot more than that.
I once got a phone call from someone who wanted to use Science Friday to teach English as a second language. I said I was so glad to hear that she wanted to use science to teach English. Well, there was a long pause, and she said, actually, I like the way you interrupt people. Yeah, I do that a lot, don't I? Or I interject often to move the conversation along. What I recently learned is that interjections are an important part of our conversations and have been studied quite a bit. And joining me now to tell us more is my guest who recently wrote all about the role of interjections for Noble magazine. Bob Holmes is a science journalist based in Edmonton, Alberta, Canada. Welcome to Science Friday.
Thanks for having me.
You're welcome. Okay, so you've written about the role of what linguistics call interjections. Can you define them for me?
Well, basically, they're short utterances, usually a single word, that aren't part of sentences and don't really, convey specific information the way a sentence does. Linguists used to think they were sort of the detritus that accumulates around the edges of conversations when we're not as articulate as we want to be. We say, and, those sorts of things. But it's turning out that they're actually doing a lot more than that they're important traffic signals for keeping conversations flowing and for sort of lining up what you and I actually want out of a conversation.
Uh-huh.
Exactly. Yeah. That's an interjection. It's called a continuer.
See, I did it again there.
Yep. And it encourages the talker to keep going. Basically, you're saying, yeah, I'm with you. Let's go. And that turns out to be really important. There's a wonderful experiment that was done some years ago where the researchers had volunteers tell each other's stories. And sometimes the listener was just told to listen, but other times the listener was told to count the number of words with the letter T in them. And that meant that the listener was paying very close attention, but they were so busy figuring out, did that start with a T, that they neglected to give the usual mm-hms and ooh, those kind of little interjection feedback. And it turned out that the speakers couldn't talk nearly as well without those continuers going, that they rambled on, or they cut their story short abruptly, or they over-explain things or under-explain things. It really dramatizes how important those are to storytelling. You need that feedback to tell it properly. Yeah, and there's another good example,
That's a good example. Why is that such a good example?
Well, especially the rising is what they call a repair initiator. It signals that something went wrong with the conversation. I didn't quite get what you were trying to tell me, and we need to stop and fix that. And it turns out that every language ends up with something very similar, because it's basically the shortest syllable you can get out.
Right. So right is right another one.
Yeah, it probably is, yeah.
So beyond traffic signals, when to keep going, when to pause, tell me about some of the other roles of interjections.
The other big role, besides sort of regulating whose turn it is and those sorts of things, is what linguists call grounding, which is basically when we start a conversation, we kind of have to negotiate between ourselves what you knew ahead of time and what I knew ahead of time, and what you want out of the conversation and what I want out of the conversation. So we're sort of figuring out where each other is coming from. And these sorts of interjections are often important in that too. One example would be, if you were to ask me what the weather was here in Edmonton, I might say, well, I haven't been outside yet. And the well, which isn't really part of the information content of what I said, is essentially a flag that says, I know I'm not answering the question you asked, but it's because I haven't been outside yet. So it's helping with the grounding.
Being Canadian, I have to ask you about the Canadian A.
Yeah.
Tell me, is that special?
It is. It does a lot of things, actually, but one of the things it does is to flag essentially my knowledge about your knowledge. If I organize a surprise birthday party for you, and you come in the door and all your friends jump out and say, surprise, it would make no sense for me to say to you, what a surprise, because I'm not surprised. I organized the party.
Right.
But it's perfectly okay to say, what a surprise, eh? Because the A flags that I knew this, but you didn't. And so it's a marker to help us indicate our knowledge about one another's knowledge. And actually, some languages do this with proper grammar. Mandarin Chinese apparently has a different grammatical structure for I'm telling you something that I don't think you know, or I'm telling you something that I think you do know already.
So all languages you're saying have some sort of interjections.
Yeah, and they're all doing pretty much the same thing. There's continuers, there's repair requests, there's placeholders.
Now, what about sign languages? I mean, do signers use interjections?
They do. They do. Yep. So I mentioned earlier that is a really good continuer in spoken language because it's unobtrusive. Your mouth is closed, so you're clearly not intending to speak. What you do if you're signing a continuer, you sign yes often, and you sign it down low with your hands in your lap instead of up sort of in front of your chest. So it's an unobtrusive signal that, yes, I'm paying attention, keep going.
Who knew? Wow, thank you. Even AI-generated audio slips in a few interjections. You asked Google LM to generate a podcast about interjections, and here's a clip of what happened.
People have kind of dismissed interjections as primitive.
Yeah.
As outside of proper language.
Mm-hmm.
Like back in the 1700s, this guy John Juan took.
Oh.
He even called them.
To me, it sounds pretty impressive considering it's AI, but here's what linguistics researcher Martina Vilchko makes of it.
My first impression when I listened to this was like looking at those AI-generated pictures where at first sight they look good, but on closer inspection, like there's one finger too many or something is off.
Huh, Bob, what's off here?
I agree. It sounds really good to me too, but once Martina pointed it out, there are little tiny tells there, like when the listener says, the speaker pauses for that. And we don't do that in normal conversation. The just sort of comes over top of things. So the timing is not quite right. And if you listen to a longer clip, also it turns out that the who knows what part, the grounding, is confused too, because occasionally, first the man seems to know what's going on and the woman is asking him for explanation. And then after a while they switch and the man starts asking the woman for explanation. The AI doesn't really understand who knows what.
Yeah. See, I'm doing it here again myself. I am certainly going to be more aware of this now that you have pointed this out. And after your reporting, you must be also.
Yep. It's definitely made me more self-conscious about and things like that.
Well, Bob, thank you very much for taking time to be with us today.
Happy to do it.
Bob Holmes, contributing writer at Knowable Magazine, based in Alberta, Canada. After the break, how the artificial sweetener saccharin can, believe it or not, kill antibiotic bacteria.
Well, this is what was happening with these bacteria. They were getting these bulges and all of a sudden they would pop quite dramatically. It was fascinating to watch it on the microscope.
Our next story is unexpectedly sweet. I'm talking saccharin. Researchers have discovered that the artificial sweetener has powerful antimicrobial properties. Tests suggest that saccharin can actually kill antibiotic resistant bacteria and, with the help of traditional antibiotics, may even be used as an effective wound treatment. Joining me now to tell us more about this fascinating research is Dr. Ronan McCarthy, professor in biomedical sciences and director of the Antimicrobial Innovation Center at Brunel University of London. Welcome to Science Friday.
Thank you very much for having me.
You're welcome. I'm fascinated by this. What would make you decide to look into saccharin? I mean, what made you think, this might have antimicrobial properties?
No, that's a great question. So my lab actually has a history of looking at compounds that are present in the diet and exploring the impact that they have on bacterial behavior, bacterial communication. And when I started to look into the history of artificial sweeteners, I was really surprised to see that many of these were synthetic compounds that were never really meant to be in the human diet. And in the case of saccharin, for example, it was discovered by accident by a scientist in the late 1800s who was trying to make new coal tar for building roads. And he licked his fingers by accident at lunchtime and found this incredibly sweet substance that subsequently went on, he developed as saccharin, as the sugar substitute. So we decided then to basically take a whole selection of these artificial sweeteners that are very common in the human diet and explore the impact that they have on bacteria, because there's been a huge amount of work exploring the impact that they have on humans and human cells, but very little in comparison then to the impact that they had in bacteria. So that was the initial starting point for this study.
So were you surprised by this?
Massively, massively. I still remember the day the student was doing the experiments in the lab, and she came down to my office and she showed me the data, and I was blown away because we had this sweetener, saccharin, that was essentially killing this multi-drug resistant bacteria that traditionally is incredibly hard to kill with antibiotics. So it's an incredibly exciting finding, one I almost didn't believe to begin with. So I asked her to go back to the lab and do it 5 more times, and then we can have a conversation again. And she did it, and sure enough, the data held up, and it was a real nice starting point for this.
So let me get this straight. So saccharin was able to kill bacteria that we currently don't have effective antibiotics for.
Yeah, exactly. So we use a multi-drug resistant clinical isolate of a bacteria called Acinetobacter baumannii, which is considered by the World Health Organization as one of the top priority pathogens because it has this incredible capacity to evolve and acquire resistance to antibiotics very, very quickly. And it makes it then incredibly difficult to treat. And yeah, then when we tested saccharin against this bacteria, it was able to kill it.
What about stuff like MRSA?
Yeah. So very interestingly, the spectrum of activity for saccharin was really quite interesting as well, because we showed that it was active against clinical isolates of E. coli, multi-drug resistant Staphylococcus aureus, Klebsiella pneumonia, Acinetobacter, as I mentioned, and also Pseudomonas aeruginosa. So real kind of hit list of priority pathogens that are very, very problematic in a hospital setting in particular.
Wow. Okay. So you have to tell me how saccharin does this. I mean, what unique properties does it have? How does it go about doing its deadly work?
Essentially, the cell envelope, which is the layer that coats the surface of bacteria and essentially holds all the content of the cell together, we saw that was being weakened significantly, so much so that when we literally observed the cells under a microscope, they very quickly started to lose their traditional or normal shape, and then we would get these bulges in the membrane. Now, anybody who's ever driven a car, one of their car tires gets a bulge in the car tire, you immediately obviously have to take it to the mechanic to stop the tire bursting. Well, this is what was happening with these bacteria. They were getting these bulges, and all of a sudden they would pop quite dramatically. It was fascinating to watch down the microscope.
Wow. Oh, so can you just then use saccharin itself and put it, to treat a wound, let's say?
So that's the route we're going, and we've developed wound dressings where we can have high concentrations of saccharin and put them on a wound. And one of the very, very exciting things we've observed with saccharin is with many of these multi-drug resistant bacteria, they form these communities or these structures, particularly within wounds, but in many sites in the body, called biofilms. And these biofilms essentially encase the bacteria in a protective matrix composed of polysaccharides. And when the bacteria grow in these matrices, they're incredibly difficult to treat because the antibiotic cannot get in to actually kill the bacteria. And there's plenty of studies out there that show it's between 10 to 1,000 times more antibiotic you need to get bacteria in a biofilm or to kill bacteria in a biofilm. Now, what we saw with saccharin is that not only does it stop the bacteria forming these biofilms, but even if the bacteria has already formed one of these protective biofilms, saccharin can disrupt and dismantle that protective structure.
No kidding. So have you actually created a wound dressing using saccharin?
Yeah, so we've created a wound hydrogel dressing. And I suppose this is another barrier that commonly faces antimicrobials that are in development, is that they work great when they're purified, but when you put them into a wound dressing, for example, they lose an awful lot of their activity. But we were really surprised and excited to see that when we integrated saccharin into a hydrogel wound dressing, that we were able to retain its activity and it was still effective. So we're currently, we've tested this in ex vivo models where essentially we've taken pig skin, we've infected the pig skin and then put the dressing on, and seen that actually the saccharin wound dressing works better than some of the antimicrobial commercial wound dressings that you can buy in your pharmacy.
That's amazing. So, our listeners are all going to hear this and they're going to want to try this at home. Are you going to tell, don't try this at home?
Oh, yeah, absolutely. We're still at the early stages of development for this. So this isn't something you could try at home. The concentrations we're using, and it's very, very important to highlight this, the concentrations we're using are not a concentration that anybody could possibly ingest. They would need to be drinking 500 cans of Diet Coke to get anywhere close. But we're very excited about how quickly we could maybe translate this into something you could potentially buy in your pharmacy or that would be rolled out in hospitals. Part of the reason for this is the active ingredient that we're working with here is saccharin, a compound that there's a huge amount of human pharmacokinetic data out there about how the body responds to it. So it should hopefully mean that it's accelerated through the development pipeline much quicker than a brand new novel antimicrobial compound that there is no data on how the human body responds to it.
All right. So the big picture, do you think this discovery could make a dent in the global antibiotic resistance crisis?
I absolutely do. I mean, one of the more exciting findings we've also found with saccharin is that it can make a bacteria sensitive to an antibiotic that it was previously resistant to. So I mentioned earlier that saccharin weakens the cell membrane. And what we've noticed is that allows more antibiotic into the cell. And that's a really exciting finding because as we've mentioned and highlighted, so many of these bacteria are resistant to the antibiotics and we need ways to make the antibiotics work better.
Well, Dr. McCarthy, thank you for sharing this really interesting research about saccharin with us.
Thank you very much for your time.
Dr. Ronan McCarthy, professor in biomedical sciences, director of the Antimicrobial Innovation Center at Brunel University of London. That's about all the time we have for now. A lot of people helped make this show happen.
D. Peter Schmidt.
Fraser Gucci.
Kathleen Davis.
Santiago Flores.
I'm Ira Flato. Thanks for listening.